Hello, good morning. This is Dr. Vijayakumar, Head of the Department of Physics, SNS College of Engineering. This is another one topic we discussed from the new engineering material. The topic is density of state in quantum well, quantum wire and quantum dot structures. So we think about what is a form of different types of quantum nature to calculate free electron density and which orbital has the highest electron density and what is a bulk material in physics. Based on this thinking question, we start in the density of energy state in a metal. So the number of electron state per unit volume per unit energy at energy E, this energy density is a factor in many of the electrical property of solids. So independent of the dimension L, the expression can be applied to the bulk material. The Ne del E is equal to Ge Fe del E. The Ne is the number of particles per unit volume with the energy between E and E plus del E, and Ge is a density of state of number of energy state per unit volume in the interval of difference of energy. Then F of E, we know that the distribution function or probability that is a particle is in an energy state of E. Then del E is a energy interval. So the DOS, that means the density of state is essential the number of different state in this particular energy level that electron are availed to occupy it. That is the number of electron state per unit volume per unit energy. So the number of electron state per unit volume per unit energy at the energy E, that is called its form of the density of energy, is based on to the form of electrical property of the solids. So the result is independent of the dimension, which as chosen above the showing the expression already we discussed that. So the electron or fermion, the distribution function is the Fermi-Dirac distribution function. So this distribution determines the probability that a given energy state will be occupied, but must be multiplied by the density of state function to weight the probability by the number of state available at a given energy. So this is a diagram to be explained in three-dimensional form: Nx, Ny and Nz. So the three coordinate axes to based on the number of electron to be occupied in a different unit cells of form. So the determination of how many way there are in obtain an energy to be incremental energy ranges of dE. So with a quantum mechanical particle in a box, the energy function is formed in a defined walled box is, we know that is n vectors. So the energy equal to n1 squared plus n2 squared plus n3 squared into h squared by 8ml squared. M is the mass of the electron, L is the length of the box, then h is a Planck's constant. So the energy can be expressed in the terms of R, and R equal to 2 root 2 me L divided by h, or E equal to h squared R squared divided by 8m L squared. So in this calculation mode, the density of energy or electron level in a metal particle, it becomes small radii allowed to the energy band structure. So size depends. The G8 makes in a Fermi energy of a particle determined on the. So the density of state to the based on the energy level, it will be formed in a different graphical representation. First one is bulk. So the curve is formed in clear line. Then E well, that means the quantum well, it's a form of dotted structure. Then E wire, it's a form of 2D dimensional. Then E dot is in a 3D dimensional. So think it, what is a quantum size different in nanomaterial, how many dimensions are in a quantum dot existed confined, what are the properties of nanomaterials. So the bulk is 3D, quantum well is 2D, quantum wire is 1D, quantum dot is 3D. That means quantum dot is 0D. The quantum confinement is a form of dimension of a material to reduce from a large or macroscope size, such a meter, centimeter, to a very small size. The properties remain the same in first, and the small change begin to occur until finally when the size drop in 100 nanometers. So this all is in a nanometers to the form of nanostructure, crystals. Electronic energy are not in a continuous to the form of crystals. So because the confinement of the electronic wave function of the physical dimension of the particle, this is called a quantum confinement. So the quantum confinement is a form of different range to the form of dot to different colors wise. So how begin a quantum dot, and what are the properties of quantum dot, and what is a quantum wire in a nanotechnologies. So this is all the reference I prepared from this PPT. Thank you very much. We discuss in another one topic in future topic of